Use binomial theorem if you want.
No.
No, don't like that. Okay, let's use non-binomial theorem. Let's let's square it.
No, let's go back.
Nah, you've chosen your path. All right, 1 plus 2 root 3i minus 3. You happy with that? 1 plus root 3i still to multiply by. So this becomes minus 2 plus 2 root 3i times 1 plus root 3i. All right, let's do this multiplication. So what do we get? Well, start with minus 2, then minus 2 root 3i. These two then plus 2 root 3i. And then what are these two together? Minus 6. So these cancel, and we're left with negative 8. Okay.
I thought it'd be like some goofy answer.
Well, I actually didn't know what the answer would be because I just picked a random example. Okay. But you can see how that's a slight bit of work if it's cubed, but you could see if we had to do that again to the power of 8 or something, that'd be a bit of a nightmare.
Wait, isn't it if it's cubed, shouldn't there be an I in it?
What?
It cancels out. It's squared. It cancels out.
I don't think so. Yeah, I think the i's just happen to cancel out. Yeah. So 0, you have an I, it's 0i. Well, let's see if we're right. We might actually be wrong, maybe, and then we can check it because now we know DeMoivres' theorem. Spell it right. Okay, DeMoivres' theorem. I said DeMoivres' theorem. So, yeah. So sometimes it's referred to DMT.
It's VR.
Is it?
Yeah.
Oh yeah. Okay.
VRE.
VR. I knew that. I promise. All right.
He was testing us.
Okay. So we have it on screen here, and we looked a little bit at this yesterday. That when we're multiplying complex numbers, what do? Multiplying complex numbers, in polar form, we add the argument, multiply the modulus. Add the argument. And then if that is applied to itself constantly, that means you can just put the modulus to the power you're dealing with, because you're constantly multiplying by the same number. So if it was 2, you'd end up multiplying by 2 a load of times, and then adding the argument a load of times. Repeated addition is multiplication. So we do cis n times theta. So that's just it's just an application really of your multiplying is add the argument, multiply the modulus. Yes, sir.
Why is there an absolute value of the modulus?
Because the modulus is a distance. It's this distance, so it can't be a negative distance. Yeah. So even if it's it's down here, that's still going to be just a positive number. Okay. All right, so let's apply this to what we know here. We're going to do the same question. So that means we have to remember how to convert. Now, we just did this question, so that's pretty easy. 1 here, root 3 here, which means my modulus is this squared plus this squared square rooted, I think is 2 from earlier on. To get the angle, I was talking to a few of you about this. How do I get the angle? I usually just go straight to tan, and I go opposite over adjacent. So tan of some angle is root 3 over 1, or root 3, and that angle I know to be pi over 3, yes. So theta is pi over 3. So I need to convert this complex number, 1 plus root 3i, into polar form, so that is now modulus of 2, and we can use our cis pi over 3. And now we're going to cube it. Okay, so we're going to cube this to see does it match our answer we got here. So following this theorem, it's the modulus cubed, 2 cubed, and my angle gets multiplied by 3. Not cubed, gets multiplied by 3, because you're adding pi over 3 times. You multiply by 3. So that's 3 pi over 3, which is pi. 2 cubed is 8, so cis pi then So you can think about that's cosine pi plus I sine pi. So where's pi? Pi is over here. That's -1 for cosine and 0 for sine. So this is -1. 8 times -1 is -8. If this is -1, this is 0. This one's going to disappear, and we're left with -8. So our answers, you can say plus 0i if you want. You don't have to. So our answers do match. So it does follow.
I feel like in this case, doing the DeMoivres
Was more work? Yeah, because you had to do a bit of conversion. Because you like algebra maybe, and you think it's quicker to multiply because you're used to multiplying squaring brackets and things like that. But you can see if this was to the power of 6, this would be far quicker. Far quicker. Do notice that the spiral thing is taken into effect a little bit. If we look at this at its individual stages, just looking at a diagram, 1 plus 3i is where we have it here. 1 plus 3i, 1 plus 3i, that's root 3i. So that's where the first one would be. The second one we have worked out here, yeah? Isn't that 8 squared? So that's -2, so -2 on the real axis, plus 2 root 3i. So somewhere here maybe. Similar scales. 2 root 3i, so that's going to have to be double that. Maybe there. Okay? That's the second one. And then the third multiplication is down, is at -8, not down. It's over here.
Do this one.
We could do the fourth one, yeah. Well, since we have it, it's easy to multiply this. Yeah, so this one is 1 plus root 3i, our beginning one. This one, I just took it from here when I squared it. Yeah, to -2 plus 2 root 3i. This one then is the -8. Now I know it's not quite on. Where's the next one going to be? Prediction?
-8 root 3i.
Yeah, so we can, yeah, you've done it, yeah. But you multiply this by root 3i again, we get -8 root 3i. And we're down for -8 here, and -8 root 3i is somewhere like down here. I'll put it in blue. It's a terrible diagram because it's, of course, running through. But you see this, the spiral start to take shape. It's going to... It's a slow spiral. Yeah, it's a spiral. You could go again if you want.
Yeah, let's go again.
You can do that in your own.
Yeah.
All right, guys.
Well, we know that maybe to the power of 6 might be one that we could see, we could get pretty quickly. Do we see that? Yeah. To the power of 6? Because that's going to give me 2 pi, isn't it?
64.
So 2 to the 6 cis 2 pi then is when I multiply it by 6. Maybe you're seeing that. So if I change this to a 6, I get 2 pi here and 2 to the power 6. What's 2 to the power 6? Quick maths.
64.
Okay, so 64 cis 2 pi is what?
Just 1.
Yeah. So 64, yeah. 1 times 64. Alex.
Sorry.
1 times 64. So it's out here somewhere on my screen. Yeah.
Are you able to get this the Argand diagram on DeMoivres?
Yeah, there's a way of doing it, yeah. Yeah. Okay. Let's look at another example. I can't remember what's coming next. So, all right, let's do this one from scratch. This is, C, can you beat me on this one? Because it's going to be quite similar. So, C, can you? Okay, I'm going to start it. So the question on screen is, use DeMoivres theorem to find the exact value of root 3 plus I to the power of 8. Okay. So my first port of call here, I like to draw a diagram. You don't have to, but I like to just to make sure that I'm in the right, I'm getting the signs right and all that, and the angle is not negative, or is it positive, or where does it sit? So this is root 3. Distance here on the real axis from here, and it's up 1 on the imaginary axis, so 1 here. Our modulus is going to be 2 again. Hopefully you're seeing that. And our angle is going to be, well, what tan gives 1 over root 3, opposite over adjacent. Or you can do sine 1 over 2, or you can do cosine root 3 over 2. It's all going to give pi over 6. So the angle is pi over 6. So I'm going to convert my Cartesian form into my polar form, which is my friend for multiplying. It is my friend, yeah. 2 cis, it's very possible, yeah. Pi over 6 So that's it when it's not multiplied by 8, but when it's multiplied by 8, so I'm going to now apply in that 8. So that's 2 to the power of 8 cis 8 pi over 6. So adding that 8 times. 2 to the power of 8. 256. 256, very good. 256. My angle then
4 pi over 3.
is 4 pi over 3, but I need to convert it back into Cartesian form. So where does 4 pi over 3 sit?
On left.
So 4 pi over 3 is past 3 pi over 3, isn't it? So it's down here. Okay, so we have to get our signs right. I think they're both going to be negative, aren't they?
Yeah.
Okay, what's my numbers going to be then? So there's,
1 over 2 and negative root 3 over 2.
Negative 1 over 2 and negative root 3.
okay, so 2, 5, 6, cosine 4 pi over 3 plus I sine 4 pi over 3. You don't need to write this step, but we can think about it if you're not sure. Cosine 4 pi over 3, my reference angle is pi over 3, isn't it? So what's cosine pi over 3?
Oh, hell no. We just 1 over 2. No,
Half, isn't it? Yeah.
Oh, is it? Oh, no.
Cosine pi over 3, a half, yeah?
Negative half.
And then when it's in this quadrant, it's going to be negative a half. Yeah? And we know that here. So it's in that quadrant. So it's minus a half. So that's the first one. That's 2, 5, 6 over 2 minus is these two combined. And I think it's going to be minus for the next one as well. It's going to be root 3 over 2 because they are in opposites. So that's root 3, 2, 5, 6 times root 3 over 2. Of course, if we want to divide those by 2,
Sir, you forgot your I.
yeah, well, okay. I haven't quite finished it. That's 128 then, minus 128 minus 128 root 3i when I divide it by 2.
Bang!
The 4?
In 4 pi over 3.
You can ignore the 4. You're going back to your trigonometry skills and reference angle because you're spinning around the circle here. It's just going to be, yeah, it's